Good morning, everyone. I want to give you a chance to get your bell work out and see if you can try this problem. Damien draws one card from the standard deck of 52. Determine the probability of drawing a jack, a spade, or a diamond. Take a moment and pause and see if you can get this one. All right, here's your clues. Remember, the union is the upside, or the U here, that's your union. The upside down one is the and. So when we did ORs, that's the union. This is the OR. And what you need to do is find the independent probabilities first. So up at the top, here's the formula I'll be using, which is a lot similar to the one we did with OR with two events. This one has three. So if you do the probability of finding a jack, probability of finding a spade, probability of finding a diamond, then down here the intersection would be jack, spade, or jack, diamond. And then the union is what we're actually after. This is the formula up at the top. So we want to actually do the OR, which is the union here. Okay, so if you have probability of jack, 4 out of 52 is correct. Probability of spade, which is 13 out of 52. Diamonds should also be 13 out of 52. So those are independent probabilities. And if you're figuring out, do I have a jack spade or jack diamond? Yes, the answer is 2. 1 jack spade, 1 jack diamond. So it's possible to have a combination of 2 of those, but there's no such thing as a spade diamond. Okay, so now that I have all the information I need, now I can put these together. If we're doing the probability of finding or jack or spade or diamond, then keep in mind we have to do the independent ones together. We're going to add these together and subtract out the intersection. So if you did that, you should have 28 out of 52. And you can see there's the 4, 13, 13 added together, and we subtract the 2, which is the intersection, and put it all over 52. Don't forget to reduce this. This does reduce to 7 out of 13, and then you'll get your decimal, which is 0.538 or something like that, so it rounds to 0.54. All right, moving on. Make sure you have that on your bell work. Today we're looking at fundamental counting principle, which basically is just exactly like it sounds. It's counting. So on these particular problems, they're going to ask you to come up with an answer using a sample space. These ones I think are a little harder than they should be, but really if you're looking at it, says you have 4 cards and 2 tiles and a game board. The cards are labeled A, B, C, and D, and the tiles are numbered 1 and 2. So if you think about it, you got 1, 2, 3, 4 cards, and each card has 2 options, A1, A2, or B1, B2, C1, C2, and D1, D2. So altogether, if you look at it, these are all the final choices here. There's going to be a total of 8 choices, possible outcomes, I should say. And we can do that real easily. Instead of doing a whole tree like this, we can just say, well, there were 4 categories, and each of them had 2 choices. So if I just multiply the cards and the tile numbers, 4 cards, 2 tiles each, the total should end up being 8 outcomes, which is exactly what we have here. Okay, and that is the fundamental counting principle. So you have event M possible outcomes and event N possible outcomes. If we multiply the 2, we get our total number of outcomes, which is what we have here. Come on down to these ones. Compound events, like what we did before, if you have probabilities, compounding consisting of 2 or more events. Remember that any event is the winners over the total. So if I want to find the compound event of getting label D and tile 2, well, this is the only label D tile 2, so there's 1 outcome out of the total of 8. So you can see that from the tiles. And then the probability reduced is the 1 over 8, and don't forget that if you were to divide that out, you'd get your decimal answer, okay, which I think is 1.3 when you round it. or 0.13, excuse me. All right, so practice these real quickly. See if you can get these three. Please read the outcomes. Which ones you want. This is finding the total number of possible outcomes of rolling 2 6s. Number 2 says find the different outfits you can make from 5 shirts, 3 pairs of jeans, and 2 shoes. And then the third one says you flip a penny 3 times. What's the probability of flipping the heads 3 times? Go ahead and pause the video and see if you can do those. All right, number 1, if you did it, each time you flip the coin, right, or excuse me, rolling a die, you're going to have 6 sides on the first roll and 6 sides on the second roll. So the total number of outcomes for two die is going to be 36 outcomes. And you can see we just multiplied the 2 outcomes together to get that 36. If you did the outfit one, you take the 5, the 3, and the 2, and we multiply. So if I have 5 shirts, 3 pairs, and 3 pairs of jeans and 2 shoes, you'd have 30 possible outfits. Okay, and on the last one, the penny, you guessed it, 1/2 times 1/2 times 1/2, you'll get 1/8, which again is the 0.13. And if you got all of these, congratulations, you should be doing good. Okay. Again, fundamental counting principle, there's the definition up here. You can read that for yourself, but basically if it just kind of boils down to however many choices you have, we multiply the number of choices to get your total number of outcomes. See if you can do example 16 here. You got 21 novels and 18 volumes. So if you look at these 2 numbers, that's really all you have. And we said as long as you have the number of choices, multiply. So here's 21 choices for the first category, 18 for the second. And if we multiply them, you should have 378 possible ways that you could read that particular novel and 1 volume of poetry. Okay. 17, this one has to do with the restaurant here. In a particular restaurant, you have 3 color choices, an appetizer, you have 5 choices for a main course, and you have 2 choices for a dessert. And then they kind of spell them out. So I guess if you want to do a tree like we did with the tiles with the letters and the numbers like on the other page, you could, but why would you want to do that when you can just take these choice numbers and multiply them together? So we said there were 3 here, 5 here, and 2 there. So if I multiply 3, 2, and 5, there you go. There's 30 possible ways you could come up with some meal options. And using the ones that are up above, they kind of describe them for you, but we're not going to list out all 30 possibilities. We just know that there are 30. Okay. Hopefully you're seeing this is just a matter of multiplying your choices. So as long as you know the numbers, we can multiply them together. Okay. Number 18 says you have a quiz consisting of 3 true-false questions. And how many ways can a student answer the quiz? Well, remember, if your choices are true or false, there's 2 choices. And if you only have 3 questions to answer, then this is just a matter of doing 2 times 2 times 2, because there were 3 possible questions and each question had 2. Okay, so on this one, you kind of have to think in terms of what each one had. Okay. You could also write this as 2 to the 3rd power, since each slot, if you will, or each question had a 2. Okay, so it's kind of like this question up here where you had 3, 5, and 2, except down here we're saying each particular question only has 2 choices, 2 choices, and 2 choices. Hopefully that makes a little more sense. Okay. All right, when you get to these examples, you kind of have to be a little bit more careful. We do have a computer password, which says it must be 8 characters long. How many passwords are possible if only 26 lowercase letters of the alphabet are allowed? And then right here in the parentheses, it says assume repetitions of letters are allowed, which is kind of saying you can have a password that has 8 characters and you can actually have all of them be the letter A, or all of them be the letter B. So that's allowed. That'd be kind of silly, but it's one of the possible choices. So the way I would set this up is, if you know there are 8 characters long, put down 8 little lines here, and in each placement you have 26 choices. So it kind of looks like this, where you have 26, 26, 26, 8 times. Or if you think about it, it's really just 26 to the 8th power. And if you put this in your calculator, or if you actually multiply 26 8 times, you still get the correct outcomes. So there would be, what is that, 208,827,064,600 possible ways that you could have a password, 8 characters long, and that's, again, with repetition allowed. Okay. All right, so these get a little trickier when we start putting in numbers and letters together, which is what the next one says. And I believe this is our last example here. So if you have a standard automobile license plate in a country, display one number followed by 3 letters followed by 2 numbers. Okay, so how many different standard plates are possible in this system? And then assuming repetition of letters and numbers are allowed. Okay, so again, you kind of have to think about how many choices are there for each number and each letter. And so they said the first one is a number, the next 3 are letters, and 2 more are going to be numbers. And for every number, there are 10 choices. And you might go, well, it's just a single digit. How can there be 10 choices? It's because each choice for a number could be a 1, 2, 3, 4, 5, 6, 7, 8, or 9. And then 0 is also possible. So that's the 10th number. So you have 10 choices for numbers, and you have 26 letters in the English alphabet. So that's why we're saying it's 10 and 26 if you're going to allow repetition. Since there are 10 numbers available for the first slot, there are 26 for each of the 3 letters in the next 3 slots. And when I say slots, I'm talking about spaces for the license plate. So you'd have 1, 1, 2, and 3, and then you'd have a 1 and a 2. So we're saying if you did 10 for this first and did 26, 26, 26 for the next 3 letters, and then 10 again and 10 again, because those are the numbers, don't forget that you're multiplying all of these together. And that's what we have down here. So you could say 10 times 26 to the 3rd power times 10 to the 2nd power, or you could list them all out like I did and multiply these together. Either way, you're going to come up with 17,576,000 for the number of license plates if you did this on top, or if you did this right here at the bottom. Okay. Hopefully this is starting to kind of sink in. All you're doing is multiplying your choices, and that's all fundamental counting principle is. You feel free to watch this video again, and then please make sure you are doing the assignment for 9-4. Thank you guys, and I'll see you tomorrow.